Welcome to the How to Program with Java podcast, where all you need is the desire to learn, and you too can become a Java programmer with absolutely no knowledge of programming. And now, your host, Trevor Page.
Hey, ladies and gentlemen, boys and girls, children of all ages, welcome to the How to Program with Java podcast. As always, I am Trevor Page, your host, and this is episode numero 52. This is where we're going to learn a little bit more about our journey through the Hibernate framework in the Java language. Isn't that fantastic, folks? But before we get into that, let's go over some 5-star reviews that I received last week. I got 2 that came in. Both looks like from the US of A, which is great. First one comes in, says 5 stars from a junior software developer. They say, I absolutely love this podcast. I've been searching for tutorials that review the basics and cover complex topics in depth, and this is just perfect for me. I listen to it on my way to work and on my way home. Love the enthusiasm and charisma to teach. Please keep up the good work. So, fantastic. Love it. Love to hear from actual software developers. It's great. You know, this person indicated that they were a junior software developer. So that's awesome. I love to hear people who actually are in the trenches doing the programming stuff and still getting use and benefits out of this podcast, because that's exactly why I do it. All right, second one came in also from the US of A, 5 stars, saying, awesome resource. Trevor does a great job explaining Java concepts. It's a great resource for beginners and intermediate programmers. I am not a complete Java newbie, but have taken a little time off from it, and this podcast has been great review of fundamentals. I have also learned more intermediate/advanced topics from Trevor. The audio format is super convenient. This is a great resource. Signed, Matt. So there you go, ladies and gentlemen. Thank you, as always, for joining this podcast. Thank you for leaving a review to Matt and to the other person who left a review. They didn't leave their name, and their name is in their username, but I don't really want to read it just in case they didn't actually want me to say their name. But in any case, thank you so much to those 2 people for leaving their ratings and reviews. If you want to leave a rating and review, you can go to howtoprogramwithjava.com/love, LOVE. Share the love, spread the word, and I will read your review on the top of the next episode if you leave a 5-star. But of course, you don't have to leave a 5-star. I don't want to pressure you guys into leaving 5-star reviews. I want them to be honest, and I want them to come from the heart. You know, it's important to me to know that I'm still keeping up with these podcast episodes, keeping up the quality, and delivering good stuff to you guys, right? Right. So, all right, let's get into today's episode, which I hinted at is going to continue being down the Hibernate road. This one is going to be a continuation of last week's. We weren't able to get to this particular topic because, well, I tend to ramble and I tend to go pretty in-depth into the tutorial, so we just didn't get there. So this week we will get there, and we're going to be talking about how to actually interact with your database in terms of the CRUD operations. I might not be able to hit every single one of the CRUD operations, but I'm certainly going to be able to get into the first couple, which is where you can insert data as well as read the data. So the C and the R, create and read. Okay? Is that right? CRUD. Yeah, create, read, update, and destroy. Although the update as well is pretty simple. But in any case, we'll see how far we get. I won't put any pressure on us to learn it all in one episode. Okay, so let's get let's do some stretches, get the neck muscles all loosened up, and get us ready to learn. Normally I don't stretch, but there you go. Got to do something new every time. So we're going to be diving into something called the @repository and @transactional annotations. So I'll say those again: @repository and @transactional. 2 more annotations that are going to be important for this leg of our journey. Probably what you'll notice is there's a lot of annotations coming up in these talks when you're talking about frameworks. One thing I said at the very beginning of the Hibernate tutorials was that you're going to see a lot of annotations, and if at all you ever get confused, it all comes back to the annotations because, like I said, frameworks tie themselves in with your existing Java code nicely and often through annotations. Cool? So we're going to explore two more, like I said, at repository and at transactional. So I guess the first one we'll talk about is at repository. So when we talk about creating, reading, updating, and destroying data from our actual real physical database, and as it pertains to Hibernate, we are going to be talking about data access objects, DAOs. I've talked about DAOs before. I've talked about data access objects before. Both obviously are the same thing. Hopefully you remember. If not, I can give you a refresher. The purpose of a data access object is just that. It is the object that you're going to use to access the data via the object that you have created. So generally how these things break down is they break down in terms of their overall functionality. So for example, if we are creating an address book object, an entity, because we talked about the at entity annotation in the last episode, when we have an entity that is an address book, more often than not, more likely than not, you're going to have an address book DAO to go along with it. Okay, you don't necessarily need to have a one-to-one relationship between your entity objects and your DAOs. Sometimes you can have multiple entity objects that are sort of handled by one DAO. That's perfectly fine. In this case, it's a one-to-one, but who knows? That's it's completely up to you how you want to design your application. So, since we have an address book entity, I'm going to create an address book DAO. DAO being the data access object, and the responsibility of this address book DAO is going to be to to do all the functions that we talked about: create, read, update, and destroy information in the database as it relates to the address book entity. Do you see how this works? So this is kind of like we're separating our layers, we're separating our functionality, and it's nice to do that. It's nice to have your certain bits of functionality in the presentation layer, certain bits of functionality in the business layer, and certain bits of functionality in the data layer. So what we're talking about now is the data layer. We're talking about interacting with a database, therefore that goes into the data layer. So how do we indicate or not store? How do we tell our code that we're going to be doing stuff in the data layer? Well, there's no real explicit way to do that. There's no line that you draw saying, okay, all these here are going to be for the data layer. But one way that I do it is I segment my code into different packages. So one way that I do it is I create a DAO package, and I put all my data access objects in this DAO package. It's kind of just a neat, friendly way to store all of your information. If your project is extremely large, then putting all your DAOs in one package would not be advisable. You'd probably have to break them down also by their role inside of the bigger app. So let's say... I didn't, of course, come prepared with a good example, but let's say not only did we have an address book, but let's say we had to keep track of an entire, software company, and we need to keep track of not only the address book, but the payroll and the hiring, the HR stuff, and who knows, maybe you would separate your project up into certain areas. Like you'd have your HR area, so you'd have your HR package, and then within the HR package you would have your DAOs, and then maybe you would have maybe the contacts area where you actually store the contact information. So you have a contacts package, and then within the contacts package you also had another DAO package. Okay, so you kind of separate your DAOs in that fashion. But for now, for these purposes, since the project we're building here is small, I'm just going to put all the DAOs into one package, which is just off of the main package that we've named, which is, for me, it's com.howtoprogramwithjava.addressbook. Okay, that's kind of the package that I've created, or maybe it's .example. I don't know, whichever name I decided to give to it when I put these what are these called, examples up on the web. So okay, fair enough. So we know how to organize our DAOs, but like I said, how do we know where this line is in the sand of our data layer? Well, another way to sort of organize our objects into, like I said, presentation layer, business layer, and data layer. To organize them in the data layer, we also lean on these annotations, such as @repository. So the @repository annotation is one that comes from the Spring framework. Okay, and it's that's why I'm teaching Hibernate, because Hibernate and Spring go together very well. So when we annotate an object with the @repository annotation, we're telling our Spring framework that this is going to be a data access object. Okay, it's our flag to say, okay, this is a data access object. Therefore, what it does is it treats it like it would be part of the data layer. Okay, and it sort of opens up some doors for us to use this object like it is meant to be used as a data access object. All right, so that's fairly straightforward. Like I said, it's one annotation, easy to do, easy to use. It goes in the class level. It's called @repository, and you'll need it when you create your DAOs. Cool. So the other, or rather the next annotation that I'm going to be talking about is going to be the @transactional annotation. Now this one holds a little bit more oomph in it. It holds a little bit more functionality. It opens up your world a little bit more. The @transactional annotation tells your code that it should be run within a transactional context. Now, I haven't talked about transactional contexts yet, and that was on purpose because it is quite a beast of a topic in general. I haven't obviously dived into it yet. I'm going to dive into it a little bit right now. But like I've said many times, my expertise lies in the Java programming language in general. It doesn't necessarily lie in the inner workings of things like transactional functions and database interactions and this kinds of thing. I know how to use it, and I know how to create applications that use it, that run successfully, that don't have any issues with it. So, I mean, I know how to use it, but I'm definitely not an expert. I can't go in depth into these things. And like I said, that's not my intention. My intention is not to go absolutely crazy and go in depth and confuse the heck out of you with all the different things that you can do with things like a transactional database and a transactional annotation. All right, that's not the scope of these kinds of tutorials. If you really desperately want to learn more about transactions, you can absolutely go on the web and you can dive real deep into the rabbit hole of learning all about these kinds of things. Okay, my goal is to present this information to you in a plain, easy, understandable manner, obviously in plain English, such that you can get up and running with your own programming in your own time. Okay, that's the goal here. In any case, the @transactional annotation is not only useful, it's quite mandatory, because if you don't have it, you're going to get an error when you either start your application up or when you try to actually do the CRUD operations on your database. Okay, you're going to get an exception saying something that the session transaction has not yet been started or something like that. I forget the exact error. Perhaps I can recreate it for you guys. But the whole point is that it allows you to open up a transaction with your database and actually be able to interact and communicate with your database. Now, I suppose what I can tell you and talk about a little bit is what transactional really means. So what that means is it's going to start... transactions when it comes to databases is all about safety, okay? It's all about being as safe as you possibly can with your data that you're inserting and modifying in the database. When a database command or operation is said to be transactional, it means that it can be undone. It can be rolled back. Okay, that's a terminology that's used in, I believe, most databases is rolling back. So what that means is, let's say you are about to insert a row of data into your database. let's say your database is completely empty. You've got an address book table. There's absolutely nothing in it. You're about to insert a row of data into your address book table. Let's say you're putting in, an entry for myself, for Trevor Page. You're putting in my name, my phone number, my address, city, state, all that stuff. You're putting that into, or about to put it into the database. What we do is we open up a transaction with the database. We open it up, and what that does is it sort of saves the current state of whatever it is that you're touching. So if you're touching the address book table, it sort of saves its state. Now, again, I can't get into specifics about how it goes about doing that, or how much it saves or anything like that. All I know is that it is a snapshot that if anything goes catastrophically bad, it can roll back and to the previous state that it used to be in, which is a known functional state. Okay, we assume that the state that the database is in right now is a good, functional, error-free state. Okay, so what we do is it opens up the transaction, it saves the current state, it then does the insert of the data into the database table. Okay, so it actually goes through all the appropriate means by which to insert the data, and then if and only if it has successfully inserted the data properly, does it do something called a commit. Now, what commit means, it says, okay, we have given a shot. We've tried to insert the data. The data seems like it has inserted correctly, and everything looks just fine. There's no errors, nothing unexpected happened. So we're going to mark this transaction as being complete. We're going to say, yes, we're good. We are committing to this insert, and we are now officially done messing around with this particular piece of data in our database. And we're done. And we walk away, we wipe our hands, and we say, good. Then if we were to select from the database again and read from the database, we would see that the row that we expected to, or that we were wanting to insert, is actually now in the database. It has been inserted. Everything is A-OK. All right, that is sort of the life cycle of a transaction if everything goes A-OK, and that's great. That's what we expect to happen. When we try to insert a row into the database, we expect that row to be inserted such that when we select from the database, we expect to see it afterwards. We expect to see everything there, right? That makes sense. Now, in the event that there was some sort of catastrophic failure, the transaction will actually roll back. So again, let's say we go back to square one. We're about to insert the row into our database. Everything looks fine. There's nothing in the database yet. We go to insert the database, and let's say we lose our connection with the database. Something goes wrong. Maybe someone turns off the computer, our server, or something like that. And let's say the database was only half done actually inserting the data. Let's say it got as far as putting in my name, my phone number, but then everything else was not able to be inserted. What happens? Okay. Well, what happens is it's going to roll back. It's going to detect that there was a failure, and it will stop trying to do whatever it's doing and immediately roll everything back to the point where it used to be in a good situation, a good scenario. Okay, it rolls it back to the point where there's nothing in the database. This is our example. Our particular example is there's nothing in the database. So that is the state it will roll back to. It will get rid of the insert that we had just tried to do, and voila, it is now back to square one, being empty. So, I mean, obviously there's a whole bunch of stuff that can go wrong when you're trying to insert stuff into a database. Like I said, someone could turn off the computer. Maybe the hard drive is full. Maybe there's some sort of I/O failure. Maybe a disk drive actually fails. Who knows all the horrible things that can go wrong with databases. But the most important thing is the integrity of the data. We don't want our data, when it's being inserted, to be corrupt. Because if we have corrupted data in our database, that can cause all sorts of bugs and all sorts of problems in our software that could potentially go unnoticed for quite some time, and could potentially take quite a while to debug and to actually get to the root of the problem and have a developer point to it and say, oh, hey, here's the problem. It's this piece of data is corrupt. It only has a first name, a last name, and a phone number in the address book table, but nothing else. And maybe the reason there's nothing else is causing all these bugs everywhere else that maybe were tough to find or something. So the integrity of the data is obviously very important, and thus having a transactional connection, having the connections be transactional in nature, is very advantageous. Okay, so in this case, in our case, actually having the transactional concept in place is actually mandatory, because if you don't put @transactional, Hibernate is not able to actually make a connection. Now, that might not hold true in every single case, but I know that if I were to take the transactional annotation away, I wouldn't be able to actually code correctly. Okay, it wouldn't, either the application doesn't start or it doesn't allow me to insert data into the database properly. So I just, by association, assume that it's quite required to use it. And I mean, I don't know why you wouldn't want to use it, because it's all about, like I said, the integrity of your data, and that is very important. So @transactional is the annotation that we want to use. This one can actually go on the method level or the class level. If you put it on the method level, you can specify only certain methods to be transactional and others not to be transactional. All right. I'm not sure if I played around with that before, and I'm not sure if I can say if that works or not. But I know that what I do is I just put the transactional annotation at the class level, so it applies to every single method that I have in there. Because more likely than not, every single method that you create within the DAO object is going to be related to opening a connection with a database and interacting with a database in some capacity or another. Because like I said, this is a DAO. This is a data access object. That's the kind of methods you're going to be creating in here, is the kinds of methods that will connect to the database and do some sort of CRUD interaction with the database. So it just makes sense to have all the methods be transactional in nature. All right, so the next topic on tap here is going to be the rest of the DAO, because right now all we've talked about is the annotations at the class level, which is above the class declaration. So now we actually need to get into the meat and potatoes of the actual DAO class. So what do we put inside of it? Well, what you need to know is that you need to put in something called a session factory. Now, this uses the factory design pattern to get and maintain sessions. Okay, so sessions are what you need to actually interact with the actual database. Okay. Now, all we need to do is, this comes from the Hibernate framework. We actually just create an instance variable called session factory. So we declare it as session factory, and we give it a name for that variable, which we can call it session factory if you want. You can call it session. You can call it, SES, SES. Sometimes people just abbreviate it. Obviously, completely up to you. It's just a variable name. The important part is that it is of the type session factory. Okay, so fair enough. That's what we need to do. We need to create that, and then we will actually auto-wire that in. So I'm going to put the @auto-wired annotation above the session factory declaration. So what that's going to do is it's actually going to properly wire in the actual session factory object that was created by Hibernate at the runtime. So as soon as the application server comes up, or rather the web server comes up, it will create, instantiate a session factory, and if all goes well, it will be a correctly instantiated session factory, and it will be injected into our DAO. Now, a word on good form for our code. Normally, I would recommend that you put something like this code that I'm talking about into a base DAO, but I don't want to get too bogged down into the minute details of good code form, okay? So just keep in the back of your mind that normally this stuff, at least the session factory, is declared in sort of like a base class that can be extended by other DAOs that we create. But in any case, we're not going for good, beautiful, elaborate, and perfect code here. I'm just teaching you the stuff that you need to know to get up and running with the Hibernate framework. All right. Again, same rules apply as before. I'm not going to get too bogged down in the details. So the session factory is what you need. You auto-wire it in, and it'll be good to go. Cool, great, fantastic. Now we can actually create our methods to actually do our CRUD operations. Now, you can create the methods with whatever names you like. I typically create a save method, so I'll create a public void save method inside of my each individual DAO. So if I'm creating a save method inside of my address book DAO, what I do is I create public void save, and inside of the brackets, I actually pass in as a parameter an address book entity, so the address book object. Okay, because what I'm saying here, what I'm implying is that this save method is going to be saving an address book object that is being passed into this particular method. All right, so public void save and address book is what's being passed in as a parameter. Fair enough. So then let's say, hypothetically speaking, someone outside of this DAO has decided that they want to create an address book object. So let's say they've created it. Someone has created an address book object. They've populated it inside of the Java code. So this is the business layer now that I'm talking about. They've created their address book object. They've set all the required fields. Like let's say they set the name, phone number, the actual address, the full address, the email address, all that good stuff. And it is ready to go. Now they want to take that Java object and actually persist it. They want to take that Java object representation and make it permanent inside of the database. How do you do that? Well, you actually make a call to your address book DAO. So you say address book DAO dot save. Okay, and then you pass in that address book object. So this is the method that I'm talking about that we're creating. We're creating the save method inside of the address book DAO object. And what this method will do is it will accept that address book object, and we're going to instantiate or create an actual session. So now, like I said, we have a session factory. So from our session factory, we can say session factory dot get current session. What that will do is it'll return a session that we can use, which is synonymous with a connection to our database. Now, with that current session, name it whatever you like. I tend to name mine just session, or again, some people call it SES, just SES for short, because it stands for session, because you're going to be typing that in a lot. You get your current session, you name it whatever you like, and then you invoke the save or update method on that current session object. So you say current session dot save or update, and you pass in your object that you want to persist to your database, which is in this case the address book. And that's it. Voila, we have created our first method, the C of the CRUD. We've created that method, and that's all there is to it. Okay? I know I say that's all there is to it. I've talked a lot already about, this stuff, but when you see the code itself, it really is not that many lines of code. It's actually quite straightforward when you look at it. We're saving or getting the current session. We're saying current session dot save or update. We pass in the address book, which is the object that we want to persist to our database. And Hibernate takes care of all of the rest. All right? Because sorry, that was my phone. I'm playing around with it while I'm speaking. The Hibernate framework already knows everything it needs to about the address book object, because we've already created the address book object and hooked it into Hibernate using all of our other annotations, like the @entity annotation and the ID annotation and the @generated value annotation and the column annotations where you say the column names and all that stuff. It already has a mapping to the database, and it already knows how to map each and every single one of the fields inside of the address book object. So once we say current session dot save or update, and we pass in our address book, it says, oh, hey, address book is an object that I know about. I know about it because it is an entity. It is an entity object that has been declared as such via the @entity annotation, and I know how to map everything, so there you go. I'm just going to take everything that you've set inside of this Java object, and I'm just going to save it to my database. So it'll do an insert into the database. And that really is all there is to it. Now, if you want to get a little bit more, diving a little bit more into this functionality, one thing that is very important to understand and to note is how it decides whether it should insert a new row or update an existing row. Now, this is something that took me quite a while to really nail down and figure out, and I really don't know why, because it is quite easy to understand. I guess maybe I just didn't know where to look. But the Hibernate framework is very sensitive to the ID fields. So I made careful note not to say that I set the ID field of the address book. And that is because like I said, it's sensitive to it. So if you do not set the ID field for your entity object, so like I said, the address book object, we've set my first name, Trevor Page, we've set an address, a phone number, and all that stuff. But if you do not set the ID in that object, because remember, that object has to have an ID because it's a primary key that is tied in with the database via the Hibernate's at ID annotation and the at generated value, which we talked about in the last episode. If you have not set that, then Hibernate assumes that this particular object has never been persisted before. It is a brand new object, and therefore it will be a brand new row in the database, so it will perform an insert. However, if you were to assign a value to the ID field of the address book entity object, if you assign an ID, then Hibernate assumes that this is an actual object that already exists inside of the database because it already has an ID. So that kind of implies that it exists inside of the database, because it would not have an ID unless it existed inside of the database. Because what is the ID after all? It's just a primary key that is given to that object when it is saved into the database. So it stands to reason that if it has an ID set inside of the entity object, then that means that it already exists inside of the database. So therefore, if you are asking Hibernate to save this particular entity object, but this particular entity object actually already has an ID associated with it, then it will not do an insert. It is going to do an update. It's going to update the row that corresponds to that ID inside of that entity object. So if you assign the ID 5, then it's going to look for ID 5 in that table and update it with all the values that are currently inside of the address book object that you have passed into your save method inside of your address book DAO. All right, so that's kind of an interesting thing to note and an interesting thing to understand, and an important thing to understand of how Hibernate functions. It's very sensitive to the ID that you assign, or rather do not assign, to your Java objects as you ask it to save or update. All right. Phew. So now another side note that you can take note of is I use the current session dot save or update method. So now I'm talking about, like I said, the current session. I get it from the session factory. I get the current session, which is what we use to talk to our database. When I have the current session object, I can actually invoke the save or update method, and that's the one that we're using. You can actually also use, let me just type it in now, make sure I get it right. You can also use the current session dot save method. Okay, so there's a difference between save and save or update. Those are two different methods. Method number 1 is save. Method number 2 is save or update. If you just invoke the save method, it actually ignores whether or not, at least I believe this is how it works, it ignores whether or not the object already exists in the database. So it goes ahead and it saves it. It will do an insert on that object. Okay, and I guess right now I have my own little example that I've sort of created here. I wonder if I can actually go and let me do a test. Let me actually set a value into the ID of that object. So I'm actually going to go into the address book and set an ID. I'm going to set the ID equal to 1 because I already have inserted into my own database in my own little example program that I've created here. And instead of invoking the save or update method, I'm just going to invoke the save method. So what Hibernate's going to do here is it's going to do a save, and I would assume it would try to do an insert with the ID set as 1. So I'm actually not sure what it's going to do. Maybe it'll just ignore it and it won't do anything at all because that row already exists. Or maybe it will throw an error and say, hey, I cannot insert that row because there's a primary key collision. If I were to be a guessing or a betting man, I think I would put my money on that. But that's the beauty of doing these things just on the fly, seat in my pants type of stuff. I have no idea what's going to happen, so let's see what happens. So I'm going to go execute my local host, and I'm going to go to a method that I've created and mapped to that particular, or rather a URL that I've mapped to that particular method. And I see that it tried to do the insert, and it looks like there's no errors. Let me go and refresh. Okay, so it looks like it just inserted a brand new row into the database. So I guess it ignored the ID field. So maybe that's what the save method will do, is it just ignores any ID that you've set, and it will just insert at all times. It always just does an insert. Versus the save or update, where it will be smart and it will actually be sensitive to that ID field, and it will choose whether or not to do the save or the update. So if I change my method and then rerun my code and then redo the select from the database, I see now that it does not do an insert, it does an update because I'm using the save or update method. There you go. So that's actually, we've knocked out, that's two birds with one stone. We've actually talked about the C and the U of the CRUD operations, right? We've talked about create and we've talked about update because, like I said, it is sensitive to the ID field of your entity object. All right? Sweet. So let's see. Let's go on. Let me check my time, how long I've been rambling for. Okay, we're just past the 36-minute mark, so we can talk a little bit more about the R operation, the read operation. Generally how we do it, and I'm going to program along as I talk because I find it fun to do that. I'm going to create a method that will read information from the database. Typically what we do here is I'm going to create a method. Since I'm in the address book DAO object, I'm going to be creating a method that will read the address book table, and maybe it will grab a row based on the ID. So I'm going to do a public method. I'm going to have it return the address book object, okay, because it's going to go and query and return one address book object by ID. And I'm going to say I'm going to call it get address book, by ID. And I'm going to pass in a long, because in this example I'm using an actual long as the key, and I'm going to name it the ID as or maybe I'll call it address book ID to be explicit. Address book ID is the name of the parameter that I am passing in. So I'm going to get an address book by the ID, and I'm going to return an address book. So how do I do this? In order to return an address book, I need to actually search the database. So I need to do a query on the database by the ID that's being passed in. So how do I do that? Well, like I said, anytime you want to talk to the database, you need a session. So I'm going to create a variable called current session, and the type of the variable is going to be session. And I'm going to get the session by going through the session factory dot get current session. So session factory dot get current session returns a session for me that I can use to connect to my database. And within that, I'm going to say current session dot, and I am going to, what am I going to do? I'm going to say create criteria. So criteria is sort of the one of the types of objects that you can use to actually perform queries on your Hibernate, through your Hibernate code to your actual database. So this is what we use to query. You can also create SQL queries if you want. You can use native SQL code. You can even use something called HQL, which is Hibernate's querying language. I'm not going to talk about that because I think that the create criteria is actually pretty straightforward to use after you've, again, used it a few times. Obviously, it's not going to come second nature the first time you use it. You're going to you need to practice on it a few times. All right, so how does this criteria thing work? Well, like I said, you take your session and you say, current session dot create criteria. So that's your first step in this process. And inside of the brackets for create criteria, because it's actually a method call, what it wants is it wants a class. So it wants you to give it the class that it's going to be creating the criteria or the query on. So the class that we're actually going to be querying is, class can be substituted with the word table. So what table are we querying? Well, we want to query the address book table, right? Because we want to query it and say, okay, get me an address book where address book ID equals 5 or something like that. That's essentially the query that we want to build here. But how do we tell Hibernate to do it using this criteria language or criteria, code that it has? Well, we have to put in the class. And like I said, class is synonymous with table here. So we're going to put in the create criteria, and in brackets, we're going to say address book dot class. So we're allowed to do that here. We're allowed to say address book dot class because address book is an entity object. It makes sense to put that in there because we've declared it as an entity object, and Hibernate knows what the address book class is. If address book was not an entity object, it would probably give you an error and say, I don't know what the heck you're talking about, in whatever language it is that it chooses to do that in, probably a nice complicated stack trace. Okay, so we're saying create criteria on address book.class. Fair enough, but if I were to run this would actually just do a select star from address book. So we want to be a little bit more narrow or a little bit more specific in what we're actually looking for. So how do we get more specific? Well, we say dot add. Okay, because we're going to add some restrictions. Because we want to restrict the actual size of our data set that comes back. We want to restrict it by a certain metric. In this case, it's going to be the ID, but we'll get to that in a second. So we're going to add a restriction. So we say dot add. And in this language, I don't know if you're familiar with what's going on here, but we're actually using something called chaining. I'm wondering if chaining is a design pattern or if that's just a type of. It must be some sort of design pattern, I would think. Actually, that's a good question. Let me go to Wiki here, or rather Google, and type in Java chaining design pattern. Let's see if it actually is a design pattern. Well, it looks like chain of responsibility is, but maybe it's not a design pattern. So what is? I guess it's just called method chaining. Wiki describes method chaining as being a common syntax for invoking multiple method calls in object-oriented programming languages. Each method returns an object, allowing the calls to be chained together in a single statement. Blah, 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 blah. Okay, so it's not a design pattern. That is the answer to my question I was looking for. But what chaining is it allows you to keep on saying dot this, dot that, dot this other thing, dot, 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 dot. You can keep adding more and more method calls upon method calls upon method calls. So it's very useful. It's a good shorthand for actually getting stuff done. So that's why we're allowed to say current session dot create criteria dot add, and then within the add method as a parameter, I'm going to add a restriction. So I'm going to say restrictions dot, and then I'm going to say ID equals or ID EQ. Okay, so that's a special static method call inside of the restrictions object that allows us to pass in an ID field. So I'm going to pass in the address book ID. Okay, so I have current session dot create criteria on the address book class dot add restrictions dot ID equal or EQ, and then I pass in my address book ID. It's tough to translate this over audio, like I said more and more times over and over again in past episodes, so it's going to be useful for you to actually log into the show notes at howtoprogramwithjava.com/session, what are we on, 52 right now? Session 52, and you'll see exactly what it is that I'm talking about. But in any case, I'm going to add that restriction, and I'm going to do one more method chaining call. I'm going to say dot, I think I'm going to say, what is it? Oh boy, I'm firing on not firing on all cylinders here. Not dot list. I'm gonna say dot distinct. Dot. Oh, what is it? Unique. I think it's unique. Jeez, my brain's not working. Yes, unique result. There we go. So I'm going to ask for a unique result. All right. So what that's going to do is that's sort of the final method in my method chaining process going on here. I can say either unique result or I can say list. But in this case, I don't want a list of stuff. I'm looking for a specific entry inside of my address book table. So I'm going to say dot unique result. And what that will return is an object that I can actually cast to an address book type. So I'm going to cast the whole thing to address book, and that will give me a unique address book entry from my database table. All right, I'm going to code all that in and save it, and then I should be able to see that that works properly. So again, you'll be able to see this code on the show notes page, but all you really need to understand is all we're doing is building a select statement using the Hibernate code. Okay, that's all we're doing here. So we've created a query that is filtering by the address book ID column. And what we're doing is we're passing in a particular address book ID that we want to query by. And we created the method. So now we have this sort of generic method that we can use, and we can pass in whatever ID that we want, and that will actually return an actual address book object that it gets from the database, depending on what address book ID it matches. It's either going to find one or it's not going to find anything, because if you pass it an ID that doesn't exist in the table, then it's going to give you null. But if you give it an ID that does exist in the table, it's actually going to query the database, find the result, pull that result into, the Hibernate backend code. It's going to take all of the columns and all the joins and everything that's going on, put it into and populate a Java object, return that Java object, give it to you, and then you just take it and run with it. So there's a whole bunch of stuff that happens in the background that you don't need to worry about, because that's what the Hibernate framework is meant to do. It does all the heavy lifting for you, and it just gives you the entry that you want so you can go and use it. So it's quite straightforward. It's quite easy to use this stuff once you get a hang of it. Okay, and it gets pretty flexible. You can, like I said, for this particular example, we're looking for a unique result. So we're just looking for one result. But let's say you want to pass in a list of address book IDs. You can query by that list of address book IDs if you like, and return a list of address book IDs of ones that you actually find and match to the database. You could even create a method that, actually, let's create this method. Let's create another one. Let's create public address book. So it's a public method that returns an address book. We'll say get address book by name. Okay? And we're going to pass in a name as the string. So now, again, what we do at the beginning of every method here is we're going to get our current session. So we do session factory.getCurrentSession. We assign that to a variable called whatever we like. I'm going to call it current session. And now I can say current session dot create criteria. Okay, I want to, again, create a criteria, the code that we use to query the database. I want to query the address book table, so I say address book dot class. And then I want to add a restriction, so I'm going to say dot add restriction, or restrictions, sorry. I always get that mixed up. It's a plural, restrictions. And then I say dot, and I say equal, so EQ. It always abbreviates the word equal to just EQ. So I say restrictions.eq and hit enter, and now I can tell it what property name I want to search for. So in this case, the property name that I'm looking for, I believe is, did I call it name in the address book? Yes, I called it name. So I can actually say name, and it matters what I put in here. When I say .eq and I give a property name, the property name that I put in needs to match the property name that I gave to it in the address book object. I called the person's name in the address book object private string name. So it's important that I put the exact same name of the variable or of the property in that field, in that parameter area. Okay, when I'm saying restrictions.equal, I need to put name in there. Okay, and then the value that I'm passing in, it's sort of a name and value pair. I'm looking for the property called name, and the value I'm looking for is going to be the name I want to find in the address book table. Okay, so again, I'm getting an entry by the name of the person. So I'm saying if I'm looking for Trevor Page, if I search for Trevor Page, I want to get Trevor Page's address information. So this is how you do it. And then here, let's say, hypothetically speaking, there could be more than one Trevor Page. So now instead of saying .unique result, I'm going to say .list. So now what's going to happen is it's not going to look for just one result. It's going to look for multiple results, because possibly there could be more than one person in your address book called Trevor Page. It's not very likely, but it could absolutely happen. So I want to return a list of address book objects. All right, fantastic. So now I can do just that, and I can say return the list. Okay, in which case this particular code is going to fail. It's going to say it doesn't want to return a list. It wants to return just an address book, because when I created my method, my get address book by name method, I actually called it public address book, which means it's going to return just a single address book. So I actually need to make a change to that. I need to say public list of address books is what I'm going to actually define it as. And then my code will compile nicely. So that's another type of query that you can do that's, very common with the Hibernate framework. And it gets, exponentially more difficult as you go down and start to, create more complex queries, right? Because not only, we've only touched on one type of query here. What about a query with joins? What about a query with a group by? What about a query where we order by? Okay, all these things can be done. I'm not sure if I want to get into each of them because they're very easily accessible through a Google search. You just say, how to do group by select with Hibernate. Okay, and you'll get an example of someone that shows you exactly how to do it. But most of them all use the create criteria method, which is why I'm teaching that to you now. It all sort of is based off of create criteria. All right, so very, very cool stuff. So there you go. Now you know how to create data with Hibernate. You know how to read data with Hibernate. You know how to update data with Hibernate. Now all we need to do is talk about how to delete data with Hibernate. So it's actually, again, fairly straightforward. The only difference is it's kind of like a mix between a read and a save. It's kind of what we're doing here. So when we want to delete data, we need to do a search for the object that we want to delete. The important thing to note here is that when you are going to delete an object, you can't just pass in the an object that you construct yourself. You actually need to query the database and load from the database the object that you are going to delete, because it actually keeps track of that information. It actually knows if the object that you are dealing with has been loaded from the database or not. And that's something that's very tricky with Hibernate that can kind of bite you in the butt if you're not careful with it in terms of getting exceptions being thrown. It knows if the object is attached or not to an actual database row. Okay, and that's, I believe, the terminology it uses, attached, is the terminology that it uses. So it's very important to do to load the object from the database first. So if I were to create a delete method, I can say public void delete, and I can pass in an address book, or rather maybe an ID. I'll say long ID. Maybe I'll change the name of the method to be delete by ID, and I'm passing in the ID of the address book field that I want to delete. So same thing as before. We need to do a create or get current session. And we say current session, and we say dot create criteria. Because again, like I said, we need to load the entity from the database before we try to delete it. So we create criteria, address book dot class, because we want to query the address book table, dot add restrictions, and then I actually am going to say ID equal to the ID that we are passing in. So I'm going to get that unique result. Okay, I'm just looking for one entry because I'm searching by ID. I'm going to look for that unique result. I'm going to assign it to an object. I'll call it result, and I'll define it as an address book object, in which case that means I need to cast my create criteria call. Again, you'll see this method in the actual show notes at howtoprogramwithjava.com/session 52. So there you go. So I've created a query where I'm actually querying by ID. I've got the result, and I'm going to say if result is not equal to null, then I'm going to say session or current session dot delete. And I'm going to ask for what object we want to delete, because again, we're saying current session dot delete. We haven't told it what object we want to delete yet. And we're going to pass in that result that we just queried for in the database. All right. So that is essentially all you need to do to delete an entry. Now, what I'm going to do just to make sure that my code is perfectly fine, it works as expected, I'm actually going to go into a controller that I've created and invoke that code. So I'm going to do an address book DAO.save entry, and I'm going to save the entry that I create manually, and then I'm going to invoke a delete on that same entry. Okay? And we'll see what the result is. Hopefully this will work as expected. It will probably do an update, or save or update is what I've asked it to do. Yeah. So it's going to do a save or update, and it's not going to be able to, or it's probably going to do an update because I'm passing in this object with an ID of 1, because that's what we did from before. And then, so it'll update that row, and then it will try to delete that row, and we'll see what happens. Hopefully there are no errors that get thrown, and it just deletes the row. So let's take a look. And exactly what I thought was going to happen is what happens. So that is beautiful. That is exactly what I expected to happen. So there you go. That is how you create, read, update, and delete information with the Hibernate framework. Obviously, there's a lot more to it than that. There's, this probably covers 75% of the cases that you'll run into in your programming journey. But obviously the next 25% is going to be a little bit more difficult to understand. So we will obviously be continuing this talk on Hibernate in the future episodes. So don't you worry, you're going to learn tons more about the Hibernate framework because it is just that cool. So, as always, I will have you guys and direct you guys to the show notes, as I've mentioned before, howtoprogramwithjava.com/session 52. And I am actually doing a webinar this week, which is going to be fun. I'm actually teaching something doing a webinar on the Spring framework, because that's what you guys actually asked for when I sent out an email asking you guys what you want to learn about. So I'm going to be teaching a little bit about Spring. So if you're listening to this on the day that it was recorded, which is July 14th, then you can hop on to that webinar. You can sign up for it. Again, on the show notes page, you'll see at the very top, you'll be able to click I have a little drop-down bar. It'll be, orange or green or something, and it'll stick out like a sore thumb, and you'll be able to click there and sign up for the webinar. If you're listening to this past this week, so after July 14th, 2014, who knows, maybe I'll be doing another webinar, or maybe I'll just have the ability to sign up for my mailing list, which is where you will be notified of more webinars or whatnot, or whatever it is that I may be doing in the future, because who knows what future Trevor is going to be doing to teach you guys stuff about Java programming. So be sure to get on there, either the webinar, sign up for it, or the mailing list, sign up for the mailing list, because like I said, there's lots of goodies in there, and it's just, you're going to be part of the family when you jump on there, so that's always a good thing. So until then, I wish you the very best. I look forward to the next episode. And as always, happy learning, ladies and gentlemen, and bye for now.
Thanks for listening to the How to Program with Java podcast. Please visit howtoprogramwithjava.com for more useful Java tutorials.